Now we're going to look at fractions, particularly focusing on adding, subtracting, dividing, and multiplying fractions. In this particular slide, we're going to look at adding and subtracting fractions. When you are dealing with adding and subtracting fractions, you need to look at 3 rules. Please keep them in mind. The first thing to do is to look at your question and see if we are dealing with mixed number or fractions. So in this case, where you have a whole number and a fraction, it's called a mixed number. So because we're dealing with mixed numbers, we need to first convert the mixed numbers into fraction values. How do we do that? Before we get stuck into it, I want to quickly remind you what a numerator and denominator are. In a fraction, the number above the dividing line is known as the numerator, and the number below the dividing line is known as the denominator. Please remember that. Okay, now let's convert these mixed numbers into fractions. To convert a mixed number into a fraction, we need to first come up with a new value for the numerator. To do that, you need to multiply the whole number by the denominator and add the value of the numerator to that total. So in this example, 4 is your whole number multiplied by 3, your denominator. So 4 times 3 is 12, and then you add the value of your numerator, which is 1. So 4 times 3 is 12, 12 plus 1 is 13, so your new value for the numerator is 13. As for the value of your denominator, it stays identical to the one in the original mixed number. So 3 will remain the denominator. Okay, let's try the same with the second mixed number we're dealing with. So what was the rule again? We need to multiply the denominator by the whole number and add the value of the numerator. So denominator multiplied by the whole number, 5 times 2 is 10. 10 plus the numerator's value, which is 1. 10 plus 1 is 11. So 11 is your new numerator value. What is your denominator value? The same as the denominator in the mixed number, which is 5. Now that we've converted the mixed numbers into fractions, we can proceed to Rule 2. Rule 2 states that the denominators need to be equal to each other for you to be able to add fractions or subtract fractions from one another. So in this example, you have 2 different values of denominators. You have a 3 and you have a 5. So they're definitely not equal to each other. There are 2 things you can do to make a denominator equal to another denominator. One is to see if one of the denominators can be multiplied by one number so that it equals the second denominator. So in this example, can we multiply 3 or 5 by any other number to give you either 3 or either 5? That's not possible in this particular example. So we've got to take it to the second method. The second alternative is for you to multiply the denominators by each other's value to get the common number. So what you would do with the first fraction, 13 by 3, is that you would multiply both the denominator and the numerator so that the overall value of the fraction doesn't change by 5. So 3 times 5 gives you 15 and 13 by 5 gives you 65. Then for this particular fraction, 11 by 5, you would multiply it by the other denominator's value. So 3. So 5 times 3 again gives you 15 and 11 times 3 gives you 33. So now you have the same value for the denominator, which is 15. And you can easily add 65 and 33 to give you 98 over 15. So the denominators were equal, so we were able to complete the addition. So that's step 2 or rule 2. The third thing that you need to remember is that the final answer needs to be a simplified version of the fraction. So in this particular example, you have an answer. When you add 65 and 33, you get 98 by 15. 98 by 15 can be simplified into a mixed number. So 98 by 15 is in fact 90 divided by 15 plus 8 divided by 15. So we know that 90 divided by 15 is 6 and 8 divided by 15 is the fraction component. So you have the whole number 6 and you have the fraction 8 divided by 15, and this will be your final answer. Now, you may wonder, how did I decide that I can split this fraction into 90 by 15 and 8 by 15? So this comes with a little bit of practice. So you've got to work out, using this bigger number in your numerator, what is the closest whole number that you can divide 90 by? So this might take a bit of working out, but the closest number that you can divide 90 by is 90 by 15 is 6. So you know if you divide 90 by 15, you can get 6, but there's still that leftover 8. So that's why we split this up into 90 by 15 and 8 by 15. This is your 6 whole number, and then you leave the remainder in a fraction, giving you a simplified final answer. This will become clearer and clearer as you complete more questions where further simplification or final answers are required for fractions. Okay, so now let's try and apply rules 1, 2 and 3 for the subtracting example. In this subtracting example, again we're dealing with mixed numbers, not plain fractions. So a mixed number, as you know, includes both a whole number and a fraction. So as per our rule 1, we need to convert the mixed number into a fraction. We've just done this in the earlier example as well. So how does that work? You have the denominator multiplied by the whole number and added to the value of the numerator to give you the new numerator, and the denominator stays the same as the denominator in your original fraction. So 4 times 3 is 12, 12 plus 1 is 13, and 3 is the denominator here, so it remains the same. Let's try this for the second one, the second mixed number in this question. So 6 times 2 is 12, 12 plus 1 is 13, 13 by 6 is your second fraction. So now that we've converted the mixed numbers into a fraction, we need to go to rule 2 and ensure that both the denominators are equal in value. So what were the two methods that we could use to make sure that the denominators are equal in value? First of all, you look at the two denominators and see if you can multiply either one by a number so that it is equal to the other. So when we look at the 3 and the 6, we know that if we multiply this denominator 3 by 2, we get a value of 6, which is the same as the second denominator. So that's the simplest way to go in this particular example. You multiply the 3 by 2, which gives you a value of 6, and when you multiply your denominator by a number, you need to multiply your numerator by the same number so that your overall fraction's value doesn't change, as you know. So you multiply the 3 by 2, giving you the 6 denominator, and you multiply 13 by 2, which is 26. So your new fraction is 26 by 6, and you subtract 13 by 6 from that. So because it's a common denominator now, you can do the subtraction. 26 minus 13 is 13 by 6. So we've successfully completed step 2 and reached an answer. The third thing we need to do is to simplify the fraction for the final answer. Again, we need to convert this into a simplified fraction, so we have to find the closest whole number when you divide 13 by 6. We know that 13 by 6, the closest number would be 12 by 6 plus 1 by 6, because 12 divided by 6 is the whole value of 2, and then you have a remainder of 1, and that becomes your remaining fraction of 1 by 6. So if you were to divide 13 by 6, what is the closest whole number that you would get? You would get 2. So 6 times 2 is 12. 12. From your 13, if you take away your 12, you get 1 by 6. So you get 2 as a whole number and your remaining fraction of 6. Now we're going to look at some examples involving multiplying fractions. There are two simple rules to follow when you're multiplying fractions. First, you have to look at the fraction and determine if it is a mixed number or a simple number. So if it is a mixed fraction, for example, this is a mixed fraction which includes a whole number and a fraction, you need to first convert it into a simple fraction before you can then do the multiplication. So let's look at our first example. We are working with two simple fractions, so this is not an issue for us. Rule 1 is satisfied. Let's go to rule 2, simply multiply. So we know that 2 times 1 is 2, 3 times 5 is 15. So your answer is 2 by 15. Let's look at another example. Here you do have mixed fractions or mixed numbers involved in this fraction. So you need to first convert the mixed numbers into simple fractions. How do we do that again? You multiply the whole number by the denominator, so 3 by 3, and then you add the value to the value of the numerator. So in this example, if you multiply the denominator by the whole number, 3 by 3 gives you 9, and then you have to add the value of the numerator, which is 1. So 9 plus 1 is 10. So that forms the value of your new numerator in the simple fraction. The denominator stays the same as the denominator in your original mixed fraction. So again, the rule is to multiply the denominator by the whole number and add that value to the value of the numerator, and that will give you the new value of your numerator. The denominator stays the same as the one in your fraction. Also, when you have a whole number and you're multiplying it with a fraction, any whole number can be written as a fraction using 1 as the denominator. So if you had the whole number 2, 2 by 1 is your fraction. If you had the whole number 5, 5 by 1 is your fraction. Now let's do the multiplication. So 10 by 2 is 20 and 3 by 1 is 3. You can see that you have a simple fraction. You need to now convert this into a whole number and a fraction, a mixed number, so that the answer is complete. So how do you know when you leave your answer as is or when you have to convert it into a whole number and a fraction, forming a mixed fraction? How do you know when to do that? The rule there is, if your numerator is larger than your denominator, you should then convert your final answer into a whole number and a fraction. So here you can see the 20, your numerator, is greater than the value of your denominator, which is 3. So you know you have to further simplify your answer and present it in this fashion as a whole number and a fraction. How do you go about doing that? There's a simple way to do it, and it's to see, can you identify the number closest to 20 that can be divided by 3? We know that 20 can't be divided fully by 3. What is the number closest to 20 but less than 20 that can be divided fully by 3? So we know that 18 can be divided by 3 to give you 6. We know that 21 can be divided by 3 to give you the value of 7. But what's the rule here? We need to find the number closest to 20 but less than the value of 20 that can be fully divided by 3 to give you a whole number. So in this case, the correct option is 18, because 21 can be divided by 3, is close to the value of 20, but it is not less than the value of 20. So that rules 21 out. So what's the closest value? It's 18. So when you divide 18 by 3, you get the answer of 6. So you found your whole number. So then you take the value of your numerator, which is 20, and you take away 18. You deduct the full number that you divided by 3, which was 18 in this case, from there to get the value of your numerator. So if you deduct or subtract 18 from 20, you get the value 2, and that forms the new value of your numerator. The denominator stays the same as the denominator. So let's just quickly recap what the rules are. First of all, how do you know when you have to divide or further simplify a simple fraction into a whole number and a fraction? Why can't you just leave it at 20 divided by 3, for example? How do you know when to leave it and when to simplify it further? The rule there is, if the value of your numerator is more than the value of your denominator, you have to further simplify it into a whole number and a fraction. So that's the first check. And in this case, we know that 20 is more than 3, so we've got to further simplify it. The next is, how do you do that? How do you simplify it into a whole number and a fraction? So, there are a few rules there for you to remember. The first rule is, you have to find the number closest to your numerator that can be fully divided by your denominator. So what's the number that's closest to your numerator, 20, that can be fully divided by your denominator, 3? And the third aspect of the rule is, it also has to be less than the value of your numerator. So it should be rule 1, the number closest to the value of your numerator. Rule 2 should be able to be divided by your denominator, and rule 3, it should be less than the value of your numerator. So in this instance, we know 18 can be fully divided by your denominator is the closest value to the numerator that is still less than the numerator of 20. So we choose 18. You divide 18 by 3 to give you the full number, the whole number in this mixed fraction. So you have your whole number. How do you come up with the remainder of the fraction? The denominator is easy, it stays the same. Then you have to fill in for the numerator. To find the value of the numerator, you take your old value of the numerator and you subtract the full number that was closest to it that we used to form the whole number 6. So in this case, 18. You subtract 18 from 20 to give you 2. That's how you simplify this fraction. I know a lot of you may be able to do this very quickly, but I just wanted to break down the steps for some students who may not be as familiar with this method. Now let's look at another example. This is another multiplication involving two mixed fractions. So remember our first rule, we have to convert the mixed fraction into a simple fraction. You must be all hats at doing this now, so we can quickly run through this. Multiply the denominator by the whole number and add the numerator. So 3 times 3 is 9 plus 1 gives you 10, the new value of your numerator. Your denominator stays the same at 3. We have to do the same here again for this mixed fraction. So 5 times 1 is 5, 5 plus 1 is 6. 6 is the value of your numerator and the denominator stays the same as 5. Now, there are two ways of doing this. You can multiply 10 by 6 to give you 60 and 5 by 3 to give you 15, and your answer would be 60 by 15, and then you would have to simplify that further. Or you can simplify the individual fractions before you get your answer. So you know that 5 and 10 are numbers that are divisible by the same number, which is 5, and 3 and 6 are also divisible by the same number, 3. So pretend that this 10 by 3 times 6 by 5 looks like 10 by 5 times 6 by 3. You're swapping numerators, and you can simplify by dividing the 6 and the 3 by 3. If you divide the 3 by 3, you have 1. You divide 6 by 3, you have 2. Then you divide the 10 and the 5 by 5. If you divide the 5 by 5, you have 1. And if you divide 10 by 5, you have 2. So in this, you've now simplified your answer to 2 times 2 is 4. And the denominators are both 1, so 1 times 1 is 1, and we know that 4 divided by 1 is a whole number of 4. So that's one way of doing it. In the other way that I mentioned earlier, you would multiply 6 by 10 to give you 60, you would multiply 5 by 3 to give you 15. So you would have 60 by 15. And you know that 60 can be divided fully by 15. So if you divide 60 by 15, you would also get the answer 4. If you don't want to do that bigger division, the easier thing to do is simplify your fractions before you multiply them. And how do you simplify it? You find the same number to divide them by. So the 6 and the 3 in this example, we divided it by 3. The 5 and the 10, we divided them by 5. And we simplified it so that we only had to multiply 2 by 2 to give us the answer of 4. Remember that when you are simplifying before you multiply, you have to divide both the denominator and the numerator by the same numbers. So if you've divided the 5 here in the denominator by 5, you need to divide one of the numerators by 5 as well, which is what we've done to the 10. And similarly, because we divided one of the denominators by 3, we need to divide one of the numerators by 3. So you have to divide both above the line and below the line by the same numbers. That's how you make sure you're not changing the overall value of your fraction. Now we're going to be looking at dividing fractions. So what are the rules involved when you're dividing fractions? First, you have to convert any mixed number into a fraction, similar to the way we do multiplications. And the second thing is, to do the division, you have to multiply the first fraction by the reciprocal of your second fraction. So let's look at an example and see what that means. So in this first example, 1 by 3 divided by 1 by 6, we're dealing with mixed numbers? No, we're not. We're dealing with simple numbers. That's right. So we don't have to convert any mixed numbers into simple fractions. So we can move on to step 2, which is to multiply the first fraction by the reciprocal of your second fraction. So what's the reciprocal of a fraction? To get the value of a reciprocal of a fraction, all you have to do is swap the values for your numerator and denominator. So in this case, 1 by 6 becomes 6 by 1. As you have swapped the values, your numerator becomes your denominator and your denominator becomes your numerator. And you have to multiply it by the value of the first fraction. So 6 times 1 is 6, 3 times 1 is 3. We know that 6 divided by 3 is 2. Let's look at another example. In this example, we're dealing with a mixed number and a simple fraction. So again, how do we convert the mixed number into a simple fraction? Rule 1, 2 times 3 is 6, 6 plus 1 is 7, forming the value of your numerator, and then your denominator stays the same as 3. Now you need to convert your second fraction into its reciprocal. So 1 by 6, we know when you swap the numerator and denominator becomes 6 by 1. And let's multiply this fraction now. So you can either multiply 7 by 6 and 3 by 1, giving you 42 by 3, and simplify that, or you can simplify the fraction before you multiply, which is the easier way. You know, to simplify a multiplication, you need to divide the denominator and the numerator by the same amount. So we know that 6 and 3 can be divided by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. So we know that 7 times 2 is 14 and 1 times 1 is 1, which is the same as the full number 14. Let's look at yet another example. This one involves two mixed numbers. So first we have to convert them into simple fractions. 4 times 3 is 12. 12 plus 1 is 13. Keeping the same value of the denominator, your first simple fraction is 13 by 3. 6 times 2 is 12. 12 plus 1 is 13 again. So you have a 13 divided by 6, which is the value of your denominator, and you have 13 by 6. Now we need to multiply the first fraction by the reciprocal of your second fraction. So 13 by 6 becomes 6 divided by 13, and you multiply that with your first fraction. Now let's try and simplify before we multiply this two fractions. So we know that 6 and 3 are both divisible by 3. So 3 divided by 3 is 1. 6 divided by 2 is 6 divided by 3 gives you the value of 2. We know that 13, we have two same numbers, so we know both of them can be divided by 13, so we can cut both of them off, remaining with a 1 and a 1. So you have 1 times 2 is 2, and 1 times 1 is 1. So your answer is 2 by 1, which you know any full number that is divided by 1 is the same as that whole number. So your answer in this instance is 2. Now let's look at decimals, particularly adding, subtracting, dividing and multiplying decimal values. In this particular slide, we're going to look at adding and subtracting decimals. When you're asked to add or subtract decimals, the first thing you need to do is make sure that the digits before and after the decimal point of the values in the questions line up well with each other. So in this example, you have 1.256, 3 digits after the decimal point, 2.63, 2 digits after the decimal point, and 4.2, 1 digit after the decimal point. To ensure that they line up, you can always add a decimal or two at the end of a decimal value without changing the actual value of the decimal. So 2.630 is the same as 2.63. 4.200 is the same as 4.2. So once you've lined these numbers up, it's very easy to add these decimal points. You have 6 plus 0 and 0 is 6, 5 plus 3 is 8, 2 plus 6 is 8, plus 2 is 10. You leave the 0 of the 10 and you take the 1 to the other side, you carry it over. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus the 1 that we carried over gives you 8. So the answer is 8.086. You use a similar method when you're dealing with subtracting decimals. So you have 6.56 and 1.237. As before, you need to line the two numbers up so that the number of digits before and after the decimal point line up. Because 6.56 has only 2 digits after the decimal point, you would add a 0 at the end so that it lines up with 1.237, which has 3 digits after the decimal point. So once you've lined it up, then it's a matter of doing your deduction simply as you would do any subtraction. So you can't deduct 7 from a 0, so you would borrow a 1 from this 6, and this value would be 10. 10 minus 7 is 3. Your remaining value here is 5. 5 subtract 3 from the 5 gives you 2, subtract 2 from the 5 here gives you 3, and you subtract the 1 from the 6 giving you 5. So there's your adding and subtracting decimals for you. The only thing that you need to remember is to make sure that the digits before and after the decimal point line up with each other. After that, it's a simple addition and subtraction as you would with a whole number. Now let's look at multiplying decimals. When you're multiplying decimals, it's easy if you follow these 3 steps. So in this example, you've been asked to multiply 2.33 times 1.2. How do you do that? The first step is to multiply without decimals. So let's pretend that there aren't any decimals in this question. So you're actually multiplying 233 by 12. So you multiply 233 by 12 using the normal method of multiplication, and you get a response of 2796. Then step 2, you have to count the total number of digits after the decimal point in your question. So 2.33 has 2 digits after the decimal point, and 1.2 has 1 digit, so that's a total of 1, 2, 3 digits after the decimal points in this question. The step 3 what you need to do is place the decimal from the right. So you know now that there are a total of 3 digits after the decimal point. You look at your answer, 2706, and you count from the right the number of digits after the decimal point. In this case it was 3, so you go 1, 2 and 3, and you place the decimal after the 2, so it's 2.796. So 1, 2, 3. This is how you place the decimal point. When you're dealing with dividing decimals, the first step you need to do is to align the numbers with the decimal and add zeros at the end if needed for the alignment. So in this example, you have 2.4, which needs to be divided by 0.12. So let's line them up. 2.4 divided by 0.12. You can see that after the decimal point, 2.4 has only 1 digit, while 0.12 has 2 digits. To ensure that there are 2 digits before the decimal point, after the decimal point, you need to add a 0 at the end. So once you've added the 0 at the end, you can see that these numbers align very well with each other, with 1 number before the decimal point and 2 digits after the decimal point. Once the alignment is complete, you can move to step 2. In step 2, you need to pretend as if there aren't any decimals. You can remove the decimals. So pretend you're dividing 240 by 12 and you get the answer of 20, and that's your final answer. Section 1.9 looks at chance and probability. So what is chance or probability? There's an equation to calculate the probability of an event occurring or getting a certain outcome, and that is you have to first determine the number of good outcomes over the number of all possible outcomes. Now this may not make as much sense until we look at some examples, so let's jump into the examples. A bag has 3 red balls, 2 blue balls and 1 green ball. If you take a ball from the bag without looking, what is the probability that it will be a blue ball? Okay, so we need to calculate the probability of getting a blue ball. So the equation for probability is the number of good outcomes, in this case the number of times you can get a blue ball, and the number of possible outcomes. The number of possible outcomes in this example would be getting any ball. So to fill this in, what is the number of possible outcomes? Since there are 3 red balls, 2 blue balls and 1 green ball, and if you take a ball out, the chances of you taking any ball out, you will have 3 plus 2 plus 1, a total of 6 possible balls that you can get. So the number of possible outcomes is 6 balls. What is the possibility or the probability of getting the blue ball? How many blue balls are there? There are 2 blue balls. So there's a chance of you picking out a blue ball twice, because there are 2 blue balls out of the 6 balls in total. So your probability is 2 by 6. And what we know about fractions is that we always have to write the fractions in the most simplest form. So you can simplify this fraction of 2 over 6 to 1 by 3 by dividing both the numerator and the denominator by 2. If you divide the numerator by 2, you get 1, and if you divide the denominator by 2, 6 divided by 2 is 3. So the probability of you picking a blue ball out of a bag of 6 differently colored balls is 1 by 3. Let's look at a second example. If you toss a coin, what is the chance it will land on heads? Now this question, we have to first see what are the number of possible outcomes. So if you toss a coin, what can be your outcomes? You can either get heads or it can land on tails. So you only have 2 possible outcomes. So what is the chance that will land on heads? So the number of good outcomes, it can either be heads or tails. So there's only 1 chance, then it can be heads. So your probability is 1 by 2, and that's the simplest form of the fraction, so that's your final answer. Let's look at another example. You have a pack of cards that has 13 hearts, 13 clubs, and 13 spades, and 13 diamonds. If you want to randomly pick a card, what are the chances that it will be a spade? Okay, so now we have a pack of cards with 4 different types. We know a card pack has hearts, clubs, spades, and diamonds, and there are 13 of each type in the card pack. So what are the number of possible outcomes? If you took that card pack and picked a card, what could you possibly get? What are the total number of possible outcomes? The total number of possible outcomes is always the total of all the outcomes involved. So you have 13 plus 13 clubs plus 13 spades plus 13 diamonds. You have 52 cards in total. So that's your total number of possible outcomes. It can be any of the 52 cards. What is the chance of it being a spade? Since there are 13 spades, there is 13 chances of it being a spade. So your probability is 13 by 52. This can be further simplified by dividing 13 by 13 is 1. 52 divided by 13 is 4. So you have 1/4 of a probability of picking a spade. Another way of working it out, or just to work out how we simplify 13 by 52 to 1 by 4, is you can see that there are 4 sets of 13 different types of cards, and spades will be one set of those 4, so it's 1 by 4. That's another way of working it out, but using this equation is the simpler way of working it out. What is a percentage? A percentage is a number or ratio expressed as a fraction of 100. So for example, if you say 35%, it means 35 by 100. If you say 52% in a fraction, it means 52 times 52 divided by 100. To convert a fraction or a decimal to a percentage, you must multiply it by 100. That's a little tip for you. So if you are given a fraction 1/4 and told to convert it into a percentage, you will multiply it by 100. Here you will remember the little rule that anytime you multiply a fraction with a whole number, the whole number can be written as a fraction. It's always the whole number as the numerator and 1 as the denominator. So 1 by 4 multiplied by 100 is 100 divided by 4, 25. Let's look at another example. 2 by 5. The fraction, we need to convert it into a percentage. So 2 by 5 times 100 Again, the 100 is written as a fraction where the whole number is the numerator and the denominator is 1. So you have 200 divided by 5, 40%. When you are converting a decimal to a percentage, you must multiply it by 100. When you're multiplying a decimal by 10 or 100 or 1000, you need to move the decimal point by the number of zeros in the number that you are multiplying it. So if it is 100, there are 2 zeros in 100, you need to move the decimal point 2 places. So if it's 0.35, the decimal place will move to past 3 and past 5 and land here. So your percentage is 35%. Let's look at another example. Here you have 0.125 and you're multiplying it by 100. There are 2 zeros, so you need to move your decimal point by 2 places. So it jumps to the 1 and it jumps again past the 2. It's moved by 2 places and it lands here. So you have 12.5%. Let's look at another example or a question that you can get with regards to percentages. There was 200 milliliters of milk in a glass. Mary drank 25% of it. How much milk is left? So we need to figure out how much is equal to 25% of the 200 ml of milk, because that's what Mary drank. So 200 ml times 25% in a fraction is 25 divided by 100. So 200 times 25 divided by 100 gives you 50 ml. So you know that out of the 200 ml, Mary drank 25%. 25% is equal to 50 ml. So when you take away 50 ml from 200 ml, how much of milk is left? 150 ml. Ratios are commonly written as A is to B or A to B. A is to B or A to B. Example, 4 is to 3. In a group of friends, there are 4 boys and 3 girls. So you have a ratio of 4 is to 3 boys to girls, or number of boys to girls is 4 is to 3. This is how you will commonly see ratios referred to in questions. For example, in a basket of fruits, the ratio of apples, oranges and mangoes is 3 is to 2 is to 1. What does this statement mean? As per this statement, in this basket, there are 3 apples, 2 oranges and 1 mango. The order of the fruits will match the order of the ratio. That's very important to remember. So when they say the ratio of apples to oranges and mangoes is 3 is to 2 is to 1, you can immediately know that there will be, for every 3 apples, there will be 2 oranges and 1 mango. The order being consistent across the ratio. Another rule to remember with ratios is that whenever you give an answer in ratios, it should be written in the simplified form. So, 3 is to 4 is correct, 9 is to 12 is wrong. This ratio means exactly the same thing. 3 is to 4 is the same as 9 is to 12, but 3 is to 4 is the simplified version of 9 is to 12. How do you get the simplified version of a ratio? To get the more simplified version of the ratio, you need to divide both numbers in the ratio by the same number until it can't be divided any longer. So 9 is to 12, you can divide both sides by, can you divide by 2? You can divide the 12 by 2, but you can't divide the 9 by 2, so no. Can you divide it by 3? Yes. 12 can be divided by 3 to give you 4, and 9 can be divided by 3 to give you 3. So 3 is to 4. You know that 3 is to 4 can't be divided by the same number. While you can divide 4 by 2, you can't divide 3 by anything other than 3 and 1. So 3 is to 4 is the most simplified form of writing this ratio. Let's look at another question. In a bag, the ratio of red marbles, blue marbles and green marbles is 4 is to 3 is to 2. So there are 4 red marbles to every 3 blue marbles and every 2 green marbles. Remember the sequence. If there are 36 marbles, how many are blue? Okay, let's write down the ratio in the form of an equation. So at the very least form of this ratio, if there are 4 red marbles and 3 blue marbles and 2 green marbles, how many marbles will be there in total? 4 plus 3 plus 2 is 9 marbles in total. In our question, they've said that there are actually 36 marbles. So from 9 marbles, how do you get 36 marbles? You multiply 9 by 4 to get 36 marbles. So then, how many blue marbles are there? So since you've multiplied the total of the marbles by 4, you need to multiply all of the other marbles by 4 as per the ratio. So the 4 red marbles multiplied by 4 will be 16 red marbles. 3 blue by 4 is 12 blue marbles. 2 green marbles by 4 is 8 green marbles. So if there are 36 marbles, we know that that will include 16 red, 12 blue and 8 green marbles. As per the question, they've asked us how many are blue. 12 marbles are blue, and that's your answer.